This is example 8. Let R be the region bounded by the graph of y equal to square root of x equal to 0, and y equal to 3. Evaluate double integral over R of 2xy squared plus 2y cosine x over dA. The hint is pick wisely the first variable to integrate. That means that dA, you want to do it as dx dy or dy dx. First, we must sketch the region R first. The region R is bounded by the curve y equal to square root of x. So this is x power half. And then x equal to 0. This is a vertical line, a blue curve, blue line, and y equal to 3. So we are going to highlight the region which is bounded by the one vertical line, one horizontal line, and the red curve. I have sketched the region R and highlight the region in yellow. Then we have to decide what is the type of the region. This type of region can be a region bounded by two horizontal lines. This is called type 2 region. Horizontal line, y equal to 3 and y equal to 0. So as type 2, okay, bounded by y equal to 3 and y equal to 0, two horizontal lines. Or as a type 1 region, you have two vertical lines now. One of them is this one, x equal to 0. The other one is x equal to, you can figure out where at this point now is x equal to 9. Yellow region is x equal to 9. Okay, this for x equal to 0, x equal to 9, two vertical lines. So the integral type 2 and type 1, when I do this, you have this choice. That means I integrate this function f of xy as a type 2, you should change the dA to dx dy. Okay, this is a type 2. As type 1, you should get integrate r here, f of xy into dy dx. Okay, that means your outer limit will be x, inner limit will be y. Whereas type 2 is outer limit is y, inner limit is x here. So this type 2, type 1 here. Both type 1 or type 2 as a region are possible. But you'll find that type 1 is more difficult in the process of integration. Type 2 are easier. Cool. So I will show you why is it so by using type 2 first. So in the type 2, we're actually integrating region R. The function is 2x y squared plus 2y cosine x here. As type 2, this is actually dx dy. So that means that when you try to fix the limit of the region R here, you try to fix the value of y first. So value of y from the graph is y equal to 0. Is y equal to square root x first. Sorry, is y equal to 0 to y equal to 3. Okay, so fix that this y equal to 0, this y equal to 0 on the horizontal line, and then go all the way to y equal to 3. So it's bounded by two horizontal lines, y equal to 0 to cover the whole yellow region. So you find upper limit first, outer limit first. Then you look at inner limit. So inner limit, this case I'm looking for x now. So let's look at what is the possible value of x first from this question. So we're going to fix anywhere y between 0 to 3. So anywhere y between 0 to 3 now, so y anywhere between 0 to 3. And then you see what is the possible value of x you can get. The nearest x you can get into an entry here is x equal to 0. The yellow region is x equal to 0. So let me erase this one. X equal to 0 here is when it enters the yellow region. And again out, this is the equation. Y equal to square root of x here. That means y squared equal to x now. So x equal to y squared now, right? So that means that x equal to y squared. So this is x equal to y squared. The value of x from 0, x equal to 0 here, until it reach x equal to y squared. Because y equal to square root of x means x equal to y squared. So you got the inner limit now fixed. So this is a step to get the inner limit here. So as a type 2 region, you have two horizontal lines bounded the region from y equal to 0 to y equal to 3. Then pick any y between 0 to 3. You find out, draw a horizontal line. You find that the value of x go from x equal to 0 to x equal to y squared. Okay, so this is how you find the inner limit, outer limit. Okay, you always find the outer limit first. Then from there, you fix. Once you fix the outer limit, you can find the inner limit here. We will do the inner integral first. That means that we actually integrate. Okay, we integrate x equal to 0 to x equal to y squared, and you keep y constant. So this is going to be y from 0 to 3. So integrate 2xy squared. Y is constant now, so they get 2x integrate, you get x squared. The y is a constant now, and then integrate cosine x. You got sine x here, so this will be 2y sine x, because integrate cosine x, you get sine x here. And then this is actually x from 0 to x equal to y squared dy. So you put in the limit y equal 0 to y equal 3, upper limit first, x equal y squared, and so you get y squared square, you get y power 4, so y power 6 now, plus x equal y squared, so you get 2y sine y squared for upper limit, then subtract the lower limit here, where x equals 0 now, and then because x equals 0, so the whole thing becomes 0 here, because sine 0 is 0 here. So eventually you get y from 0 to 3, y power 6 plus 2y sine of y squared dy. Now can do the outer integral from y equals 0 to y equals 3. You integrate y power 6, you get y power 7 over 7. Then integrate 2y sine y squared. So integrate 2y sine y squared, you can do a substitution. Let's say u equal to y squared. Then du dy is equal to 2y. So actually dy is equal to du over 2y. So 2y sine y squared dy by substitution method is 2y sine of u now, and dy is du over 2y. Okay, because I have u squared y squared equal u here, and then there's du dy is still du over 2y, and so this cancel 2y. To y and 2y cancel. So basically you are integrating sine u du, right? So this actually is sine u du here. So integrate sine u, get minus cosine u here. And you put the u back, u is y squared, it's minus cosine y squared plus c, right? So this is actually minus cosine y squared. Then y from 0 to 3. Now make sure your calculator is radian mode here, so that this y go in here. So you get 3 power 7 over 7 minus cosine 9. This is cosine 9 radian, so make sure you understand this. When you press calculator, then 0 power 7, which is 0, minus cosine 0. So you press the calculator, make sure in radian mode here. You can also use type 1 integral on this region. In this case, your type 1 integral, you will have a limit of x from 0 to 9, y from square root x to y equals 3. And when you do this integration, you'll find that you actually need integration by parts, and this is much more harder than the type 2 integral, just substitution only.